Okay then, well, welcome to the inaugural Transparency.dev Summit. If anybody doesn't know me, I don't know if that's the case or not, but everyone doesn't know me, I'm Al. I'm the tech lead for Trust Fabric here at Google. I don't mind admitting that this is a pretty exciting day. We've wanted to have an event like this for a very, very, very long time. We have had many talks about transparency, certificate transparency at various conferences over the years. Last year we had CATS, which was fantastic, and now here we all are together for our 3-day summit for transparency practitioners, which I think is fantastic. If I look back at sort of the CT ecosystem and how it evolved, the sense of community that we had that grew from those CT days, the communications, the sort of the tightness that we had was invaluable, I think, in having it become the reality that it is today. And so I hope that we will see a similar thing happening here too. So the schedule, echoing what Tracy said, looks fantastic. I'm super excited about it. There's such a wide range of talks across many aspects of transparency. We've sort of grown from CT now to many other applications, which is super exciting, and I'm very much looking forward to hear what folks have to say. I hope you all enjoy it as much as I will. And I think, again, just with that nod back to community, while you're here, we've got a bunch of time together. While you're here, please do take the opportunity to go and find folks that you don't know yet and say hello. Build those connections, because this is important. This is the way that stuff gets done. If you don't know who to talk to, come and talk to me, and I will introduce you to other people. If you have any problems, you're stuck, you're lost, whatever it is, then we're all friends here, so come and find me or one of the other Trust Fabric team. In fact, actually, Trust Fabric team, can you stick your hands in the air and put your biggest, warmest, welcoming smiles on? So these folks are all here for you. We're at your disposal, so find us if you need us. Right, so with that, I'll keep riffing on this community theme. So for millennia, humans have used rituals like gathering around fires to tell stories and this sorts of stuff. It's how we pass down knowledge, how we form community, form bonds, and all the rest of it. They wouldn't let me have a fire, not after the last time, but we do have our sort of ritual story that gets told at every one of these events, and this is sort of how CT came to be. So this time it's my turn to tell the story. So the year is 2010. That's it, nothing happened. It's very boring. Occasionally you might get someone wearing a tinfoil hat coming along and saying like, oh man, the man reads your browser when you go to Yahoo, but Snowden hadn't happened, and so nobody really pays any attention to it. Then the next year, and this happens, once upon a time, Did You Know Tar was a Dutch CA. It gets pwned. Its private key material extracted and turns up on the border gateway routers of Iran, where it sits and man in the middle is all of the traffic from the folks that are inside Iran going out to places like Hotmail, Google, and indeed Yahoo. So there are predictable results that come from this. It's slightly unfortunate, not least of all, because I have to go back and find the person with the tinfoil hat and apologize. But it is mildly disastrous that this has happened. And so, we think that somebody really should do something. So heads get together, we'll start thinking about it a little bit. Wouldn't it be good if certificates couldn't be issued without anybody knowing about it? Like specifically without the domain owner knowing about it. That seems like it might be quite a nice thing to have. And it would be a little bit like shining light into dark corners so you can see what's going on. And you know what they say, right? Like sunlight is great at cleansing and killing off infections. And so someones do something, and the something is draft lorry PKI sunlight. Time passes, and draft lorry PKI sunlight turns into RFC 6962. The CT team at Google is furiously coding away to write the first CT log implementation in C++ for some reason. I guess that's what we did then. So now we have, Merkle trees. We had Merkle trees for a while, but now we have logs built on Merkle trees. Time goes on, and some CAs become early adopters. because they realize that this is important, right? Like, they're in the industry of trust, and so this is a way to improve and sort of build on trust, and so they're like, yeah, we like this. Other CAs were a little more hesitant, so there might be a little bit of back and forth that went on, a bit of negotiation, but it sort of starts to happen. Folks start writing clients to have a look at the things that are in the logs and sort of other sort of related tooling. And then over the next couple of years, we start to see that an ecosystem forms. A large browser rocks up and starts requiring CT for a subset of certificates. A bit later on, another one comes along and does the same. Monitors appear, and this is the year that the venerable CRT.sh rocks up. Where is he? There he is. So the ecosystem sort of continues developing and maturing, and you know what? It turns out that it works, and together we catch tens of thousands of misissuances, we catch backdated certificates, weak keys, baseline requirement violations, and all the rest of it. And where it's appropriate, then action's taken. Appropriate corrective action is taken to ensure the safety and integrity of the TLS ecosystem, because it turns out it's quite important and we all rely on it. So, as Tracy sort of said earlier, in fact, CT works well enough that this year it wins the Levchin Prize at Real World Crypto. So I want to take a minute just to say that if you, and I know that many of you were, if you were involved in turning CT into the success that it was in any way, however small it was, then I ask you to see yourselves reflected in this as well. This is a prize for all of us, because we all pulled together to make CT work for the benefit of everybody else. Back to the story. So obviously this isn't the end of CT or transparency in general. We see new experiments, new green shoots growing. The static API, for example, is one of them, where we've taken the lessons that we've all learned over the last decade of how you build transparency systems, how you operate transparency systems, and feeding that back in to the CT ecosystem design. So it evolves and it grows. Obviously, over a similar time period, we see the same sort of evolution and growth of types and intensities of malicious activities that are outside the scope of CT. There are some here. I'm sure that you can name many, many more too. So I guess it's inevitable that with the success of the application of CT to the set of problems that it is looking to solve, we see folks wanting to apply similar properties and principles to some of these problems. So, for example, we have binary transparency, which is maybe a bit of an umbrella term, but we see that coming to answer the question of how do we safely consume and publish binary-like things. We have key transparency. How do we safely manage, share, update our keys so that we can have nice things like end-to-end encryption? We have signature transparency. How do we safely use and manage our signing keys so that we know if they're being misused? Firmware transparency. Can we sort of push these benefits further down the stack? We've got it at TLS. We're starting to see it at sort of application and binary level now. Can we go further down? Can we have it at the operating system? Can we push it down into firmware, down into hardware? What does that mean? And obviously AI transparency as well. It's I've got to say something about AI, but it is like, how do we safely sort of create and publish and consume AI models and their outputs, right? So I sort of said earlier on that we've got a wide range of talks, and we're going to hear something about actually all of these areas over the next 3 days. So it's fantastic. We've got binary transparency breakout on Thursday. We've got William Woodruff talking about transparency and PyPy. Key transparency breakout on Friday with folks from Proton and Meta and indeed Apple. We have signature transparency talks from Rasmus and our very own Hayden. Firmware transparency, I'll be back a bit later on with Martin to talk about that because I like that very much. And on AI, we have Mihai telling us about that on Friday morning. So if these are our verticals, then the tooling that we have to build these things are horizontals. And obviously, similarly, there's an evolutionary growth of those over the time that we've been using them to become more general purpose and hopefully cheaper and easier to run too. So if I sort of go down memory lane for a little bit and think back to 2013, we had that original C++ CT log, which is quite quaint. There were only 2 million certificates in the world back then, so everything went into memory because you could do that sort of thing. Now we're at like 2 billion certificates every year, which is an incredible amount of growth. So clearly that infrastructure wasn't going to scale to where we are now. So 2016, we started with Trillion. We wanted to decouple the C from the T to try to encourage these sort of other applications of transparency to happen. And I think I'd argue that it worked reasonably well. Trillion has underpinned CT until today, but it also sits underneath the Go SumDB. It sits underneath SigStore, and then it was used in sort of other less talked about places. It's used, for example, in production change auditing at a payments processor, and it was even used for like actual food supply chain and fraud work some time ago. All of these applications are, fairly large scale, and so we did start to think about, well, what would the other end of the scale look like? If you only had something that you needed to commit to in a log, once in a while, what might tooling look like for that? So in 2021, we experimented with something called serverless, which was basically Unix tools for logs, where you manage those logs as a set of files in a file system. And then more recently, we see Sunlight and Static CT API coming to sort of put many of the lessons that we learned over this time back into CT, as I said before. And so we, again, sort of trying to separate or decouple the C and the T. We've been working on Trillion Tessera, that we'll talk about a bit later on. And again, that's something that can be used to implement Static CT API, but also it brings much of those lessons that we've learned to the other ecosystems, which should probably adopt them too. So the upshot of all of this evolution, sorry, I went on at length there, is that logs are now boring and commodity. Like, obviously logs are not boring, logs are super exciting and I love them very much, but with Sunlight and Tessera, from an implementation and an operations point of view, I think we can start to now consider this part of the infrastructure somewhat boring and turnkey, which is important. We've also seen sort of the evolution of the protocols and formats that we've used over time. So back when 6962 was the only real sort of instantiation of transparency, it would be normal that everybody would copy, the STH and proof formats and all the rest of it from there. And then over time, we've seen them sort of become a bit more general purpose and reusable. So I think it's worth noting that these formats that I'm referencing here, the generic checkbook, the witnessing stuff, tiles, all the rest of it, the way these happened were through basically more experiments, right? Someone trying something, let's see how it works. Does it stick? Do people like it? Oh, they do. And then from there, they landed on the C2SP community specs repo. But this is, again, like why we're all here, right? To sort of make these connections and be able to work together, experiment together, and form consensus and move forward with new and exciting things. So with these new sort of more common and generic formats and protocols, we also start to see interoperability beyond the ecosystem level, so between ecosystems. And this is interesting because now we start to get other shared horizontal services, such as witnessing, for example, which most ecosystems are going to need. We also get a bit more code reuse, which is nice because nobody likes to have to keep writing the same things and maintaining all the same things. The other thing that's changed and evolved is sort of what we consider to be necessary for trust. It's a bit different to the other slides, but it's fun. I thought it was fun. So, back in the day, we would make things available on the internet, and you might be, I'm going to show my age here, but you might be using your FTP client to download something from Woo Archive or 2Cows for the younger kids. And then, you're downloading this over your modem and your mum's downstairs and she picks up the handset because she wants to phone Auntie Vera. Oh no, now it's all gone wrong. Did you get the file? I don't know. So we solved that by having MD5 sums that we just would plop next to the file and we can download it. Because what we were worried about then was integrity. Time passes and this is no longer enough. And we start to be concerned a little bit with authenticity as well. So we start replacing MD5 sums with signatures. I'd argue that the meaning of these signatures was never particularly clear. But certainly it means that someone had access to a private key and the thing, and then they did a thing, and now you have a signature. But a lot more meaning was implied on those things and never really sort of clarified, which was problematic. And so from there, we started to want to have some notion of accountability. So we started logging things. But here's the thing. I can't believe Al's saying this. Putting things in logs doesn't matter. I'm going to get fired. What is that matters is discoverability and verifying the claims of things in log. So discoverability, I mean that we are all seeing the same set or list of things, however you want to phrase it. And witnessing is an important part of this. We don't want split view attacks. Verifying claims, well, so I sort of talked about what the signatures mean. When we start to think about transparency and having claims in logs, it forces us to be very explicit about what the signature means. So we can add a new thing to our list of the evolution of the bar for trust. Actually, what we want is not logging, what we want is transparency. So this means that someone's accountable for the thing. That probably means that it's signed, but it also means that they've made some statements about the thing. It's not malicious, or it's reproducibly built from this git commit using this toolchain and resulting in this hash of a binary or what have you. There could be many different types of claims. But the important thing about these claims is that they need to be falsifiable. There's no good me just going up and saying, no, trust me, bro. This binary is fine. Like, somebody else needs to be able to call me out if I'm lying. So not only do they have to be falsifiable, but they have to be entities that are actively trying to falsify these claims and call folks out when they make bad claims. And lastly, they need to be discoverable so that we can be sure that those folks do see all of the claims and will try to falsify them. So we're going to hear more about this sort of closing the loop of ecosystems from Filippo, who's down there furiously writing his talk a bit later on today. But for now, I think I will just leave you with this. So our ecosystems that we love and that we're super invested in, they need us, right? So if you are a tooling person, please consider using the C2SP specs that I mentioned earlier on for your formats and your protocols. If you think that they don't work for you or they can't work for you, then let's figure out why. And what do we do to change them so that they do work for you? And an easy way to do this is to use Trillion Tessera. If you are doing ecosystem design, then ensure that your design is closed, right? So sort of, as I said earlier on, what are you putting into your logs and why? Do they represent claims? Are those claims falsifiable? Do you have verifiers that are able to falsify them, and do they exist? And at least for the sort of the discoverability part of this, the C2SP specs can help with that too. And the last point is that we need to demand transparency, right? It's not enough for us to meet here and to invent new things, new protocols, new systems. We also need to make sure that we're creating and signaling demand for the systems which embody these principles, because that ultimately is what's going to sort of help these green shoots of growth and evolution continue to grow and receive the sunlight and the sustenance that they need, because ultimately somebody's paying for all of this. So continue to raise your expectations, as we did from MD5 sums, which were the bee's knees once upon a time, now to transparency. Let's keep ratcheting it up. Ask for transparency for your dependencies, your operating system vendors, your cloud providers, your hardware vendors, like basically anywhere that you think that it's going to sort of reduce the need for blind trust and improve security. So that's the end of my fireside tale. Thank you for listening. Thank you very much for coming and being here over the next 3 days, and enjoy your summit.